definitely be out in that amount of time. Hey, y'all. Make sure I get your names before you leave, okay? I'm going to get you. Chodo, is that right? Chodo, JC. And Catherine, what's your last name? Grimmin. I knew it was Catherine. And Draco? There we go. And help me out. Huh? Oh, Folds, right? Folds. Yeah. All right, y'all. I had a student write and ask about this question number 20. This is the fall 24 exam. I think it's in your workbook, actually. Pretty sure you'll see something similar to this where you have forces that are off axis and have friction involved. So we're just going to go the same process. I want to know what is the acceleration for this block. Draw all the forces that are involved. I have a normal force, have a weight. That's equal to 150 newtons, by the way. And I know it's moving to the right, so I have a kinetic friction. And then I have this 30 Newton force that's up in that direction. I'm going to draw my coordinate system and now draw all the vectors. This is Fn. This is the y component of that F. That's 30 cosine 30. That's equal to 26 newtons. That's 30 cosine of 30 equals 26 newtons. And then I have Fw. That's 150 newtons. And then this is, I'm sorry, this should be 30 sine 30, I'm sorry, which is 15 newtons. Sorry about that. Be careful with that. Don't make the same mistake, okay, with your x and y components, especially like if you know it really well, then you might be more inclined to make mistakes, right, because you sort of do what I just did. And then over here I have 30 cosine 30. That's equal to 26 newtons. Let me write that up here. 30 cosine of 30. That's equal to 26. That's my x component. And then finally I have my fk. So in order to find the acceleration, I do the sum of the forces in the x direction. That would be 26 minus fk would equal max. But I don't know fk, so I need to figure out what fk is. But in order to do that, I need to find the normal force. The normal force I can find by looking at the sum of the forces in the y direction. That's equal to 0. That's 15 plus Fn minus 150 equals 0. So Fn is equal to 135. Okay. Just be careful. The normal force isn't always equal to the weight. So if I have some force, which you will see a problem with a force like this. If I have a force like this, I have to include the y component of that force because it reduces the normal force by whatever the y component amount is. In this case, 15 newtons. Then I can also find, the kinetic friction. That's equal to 0.1 times 135. 0.1 is the coefficient times 135. That's equal to 13.5 newtons. And now finally, I can do the sum of the forces in the x direction, which is 26 minus fk. 26 minus 13.5 equals max. That's 12.5 divided by the mass, which is 15, is equal to ax. It's either C or E, is it? I get 0.83. Yes, C is the right answer. That's one of the harder problems on the tests, and you will see ones very, very similar to it. I don't remember if it was accelerating or what the concept was, but I do definitely remember a figure like this where I had a force that was off axis like this, that's sitting on a surface and it has friction. So very definitely you'll have a problem like that. Okay?
How do you know when you're solving for fx, you said equal to 0, how do you know when to do that when it's equal to the y component of f?
I'm sorry, I was thinking of something else. Can you repeat that question?
When you solve for fn, how do you know to do that, or when it's equal to the y component of f?
Right here. Yeah. So your normal force she asked, how do I know to solve for Fn like this? Or, when I have an inclined plane, the normal force is equal to the y component of the weight, right? That's what you're asking. Always, you can do this. Always, you can draw your coordinate system with your forces, and your normal force will be in the y direction. Whether it's on an inclined plane, it'll be in the y direction, or whether it's on a flat surface, your normal force will always be right here. And so always, you'll be able to sum the forces in the y direction and set that equal to 0, at least in the case when you have a normal force. And so don't try to memorize the various formulae for the normal force. That's not going to help you because it's going to change depending on the situation. Instead, remember the process that I label all the forces, that I put them on a coordinate system with the angle and find the x and y components, and then I apply Newton's second law. And this is going to be the consistent step to find the normal force, the sum of the forces in the y direction. I know that doesn't really answer your question, but I just want to caution you because some of you, like you study so much and you try to remember every possible scenario, and that you just can't do it because like you change one little thing and then it's different. But those 4 steps will always be the same. And your normal force, I take that back, the normal force isn't always in the y direction. Sometimes the normal force is in the x direction. Do you know that? There's a problem. Let's see. Is it on this one? I don't think it's on this one. Hey, good morning. Does anybody know what I'm talking about? Well, shoot, I might have skipped it already. Oh, there it is. There's a problem here where, we work through this one. Is that okay? This is a different example of something that works out the same way. This is, what is this? This is fall 21. And here I want to know what is the minimum coefficient of friction so this thing doesn't slide down the wall. It's sort of like the inclined plane, where I have an inclined plane and I ask you what is the minimum coefficient so that this thing doesn't slide down the inclined plane. It's very similar to that. So do the same process. Label my forces. I have a weight right here. I have, oh gosh, what is the direction of my normal force? Up, down, left, right. Is it up, the normal force? Left is right, yeah. My normal force, remember, is always perpendicular to my surface. That's what normal means, perpendicular to the surface. So the wall, it's like if I'm pushing on this wall, the wall pushes back with that normal force. I can feel it, in fact. If I hit the wall, that's what's hurting my hand when I hit it. And then I also have a frictional force, and that frictional force looks like that. So now that I have all the forces labeled, I can draw them on my coordinate system. I have this force, which is 50 newtons. This force, which is my normal force. This is Fs. And then this is force weight. Once I see that, then I see that this is actually a fairly simple question because my force weight is 20 newtons. So that tells me that Fs is equal to 20 newtons. They have to be equal. And Fn is equal to 50 newtons. And I know that mu s is the ratio of those two. So it's 20 over 50, which is 0.4. But getting to this step often confuses students, labeling all the forces because it's different. The normal force, instead of where it's usually on the y-axis, is now on the x-axis. And the static frictional force, whereas it's usually on the x-axis, is now on the y-axis. But notice the steps were still the same. I did steps 1, 2. I didn't have to do step 3, resolving the vectors, because it was already on axis. And then step 4, where my sum of the forces were equal, in this case, to 0. Sum of the forces in the y direction equals 0 here. and sum of the forces in the x direction equals 0. Does that help sort of thinking about that? There's no formulae to memorize for these except the sum of the forces equals ma. Don't try to remember, oh, the force weight is this cosine theta, or the normal force is this or that, or like looking at different examples, because that's not going to help you very much. Instead, remember those 4 steps. Label the forces, or identify the forces, label them on your coordinate system with your angle, resolve your vectors, and then apply Newton's second law. All right? Other particular questions you'll have? Yeah. Yeah, of course. You'll definitely have one of those. There's one almost on every exam, I think. Let's see, there's probably one here. Yeah, here's one. It will be an inclined plane, and you will have to tell me which formulas are correct or incorrect. I recommend that you just follow all the steps and just write out, show the forces on the inclined plane. So like we would do normally. So here's my normal force. It's perpendicular to the surface. This thing would slide down the inclined plane, except it has this static frictional force. There's my force weight, and I think that's it. Yep, that's it. I can go ahead and resolve those vectors. I have Fn, Fs, Fw cosine of what? 60. Right. Remember, you got to take that complementary angle, and then this is Fw sine of 60. So let's look at this first one. Fw cosine 60 minus Fs equals 0. Sure. I see that these two forces are equal but opposite, so that's true. That's just an application of the sum of the forces in the x direction equals 0. Fw cosine 60 minus Fs equals 0. Fn equals Fw sine 60. Again, an application of Newton's second law, but now in the y direction, so that's true. Fs equals mu Fw sine 60. I know Fs equals mu Fn, and this is Fn, so that's correct. And then number 4 is the sum of the forces in the x direction equals 0. Since it's stationary, that is true. So all of those are correct. Okay? You'll have one similar to 18. It may or may not be moving, but something similar to that. Other particular questions, y'all? Y'all know how to do 18? Okay, good. Any other particular questions? Somebody did ask about conceptual questions. We can look at some of those. Just, with the conceptual questions, they're all different, but they're also all very similar. So I recommend that you work the ones on the past exams just for practice, but understand that you'll have something different. And then also the concept tests. I loaded the chapter 4 this morning. That's a good place to go. We'll finish them in class today. You're certainly going to see some like number 3, where I asked you the graphs. So be prepared for that. This is the x component of the velocity. Remember that Vx doesn't change. It's constant because Ax is equal to 0. So if I'm plotting Vx, it's not going to change. So A and C would be wrong. And then if it's left to right, it's positive. If it's right to left, it's negative. In this case, it is, which is it? Positive or negative? What is it? Positive, that's right. It's positive, so B is the right answer. Let's look at this number 4. From the same height and same time, one ball is dropped and another ball is fired. That is, I drop a ball like that, and then I fire a ball like that. Both balls have the same acceleration, do they? Yes, they both have the acceleration due to gravity. The fired ball has a greater speed. Is that true? Is it? It is true, right, because it has that additional x velocity. The drop ball requires the same amount of time to reach the bottom as the fired ball. Is that true? It is true. By the way, let me ask you another question. A similar question. What if this ball instead went up and then came back down? Would they start from the same height, but one of them goes up and comes back down? Which one requires more time, or do they require the same amount of time? What do y'all think? What's that? Right, if it goes up, it requires more time. Remember, your amount of time in air is always set by how high it goes. And so the second one in this case, because it goes up and comes back down again, would require more time. And if you think about it, I mean, if this one goes off to the side, if it goes up, that just requires more time to go up and then come back down and then travel the rest of the way down. Yeah. I don't know why I said that. You can think about it if you like, but probably important. And then the drop ball requires less time to reach the bottom as the fired ball. Well, that's the opposite of 3. So it's 1, 2, and 3 is the right answer. Be prepared for that. You'll have at least one of those, a couple of those probably, on the exam. I don't remember. You'll certainly have one like number 10, where you're doing 2 vectors, adding them or subtracting them. Make sure that you are careful about recognizing what I'm asking you to do. In this case, I'm asking you to take the double vector A and subtract vector B. So I'm doubling vector A, and then I'm subtracting vector B. So I draw vector B the opposite direction, and then I always start at the beginning and end at the end, so the answer is D. Notice there are several places where you could go wrong in this. I could draw the double vector B like this, and I would get something like that, which you would probably choose A for that, or I could draw it the wrong direction, in which case you'd probably put B for that. So there are several ways for you to get it wrong, and most of those ways are the other options. So make sure that the vectors are oriented correctly. If it's negative, that you negate it. Also make sure that you draw them in the proper order, like that, and that you draw the resultant vector starting at the beginning and ending at the end. It's an easy question. I don't want you to miss it, right? I don't want you to miss any questions, honestly. It's a lot easier on me if y'all miss any. Do you know that? My life is easier if y'all just make perfect scores. They're easy to grade. Everybody's happy. I love that. By the way, I did post your midterm grades this morning. Your midterm grades are just the average of your 2 quiz grades and your exam. Nothing else included. So it is definitely an underestimate of your grade. I know some of your athletes in those midterm grades, like your coaches, are probably going to get upset with you if you have a bad grade. But for most of you, I think the midterm grades are just a benchmark, right? They don't really affect your financial aid or anything. So anyway, it's an underestimate. I fully expect, I hope that everybody, unless you have an A as a midterm, everybody will see at least a 1-letter grade up. Because I'll drop a quiz grade, there'll be some extra credit in there, and class participation. I didn't count all those things. It's an underestimate. So if you have a D or an F, it's a kick in the butt. Okay, so come see me. I can help you if that's the case. But a lot of y'all had A's and B's. I'm glad for them. Proud of you. And C's are good too. I had a friend in college. He always said, whenever you get a C on an exam, which in physics that was pretty common. I mean, back then, more people made C's back then, I think. He would always say, C is for cookie, and that's good enough for me, like the Cookie Monster. And then say, cookie, 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 cookie. So next time you make a C, say C is for cookie, and that's good enough for me. That's what C means, good. Average, I think it means actually. Doesn't mean average. B means good. A is excellent. B is good. C is average. All right. Anyway, what other questions, y'all? Particular questions? Particular questions? Y'all have any particular questions? Come on, y'all. It's the hardest exam of the semester. Let's have something. Number 11 on this is this exam? Yeah. Oh yeah, these are tricky. I don't remember. I have a vague memory that this is on the exam or something similar. When I say it's on the exam, it'd be a similar scenario, but the options will always be different. Okay. So a person is in an elevator. It's holding a 10-kilogram mass, as shown here. It's pretty heavy mass. He exerts a force F to hold it in place. Which of these is true? The force F is dependent only on the mass of the block. That's not true. It also depends, is the elevator accelerating upward, or is it accelerating downward, or is it stationary? So that's not true. Excuse me, not true. I do checks for true, X's for not true. I recommend that you have something else that's consistent, because we just have a lot of these types of questions. Negative acceleration means the elevator is moving downward. Not necessarily. It can mean it's moving downward, like if it's going downward and it's speeding up, that would be negative acceleration. Or if it's going upward and slowing down, that would be negative acceleration too. So that could be true, but it's not necessarily true. If the elevator accelerates downward, F is smaller than the weight of the block. Yes, that's definitely true. Let's just imagine if I have an object and it's accelerating upward, my force tension, which is the force the person is exerting, and my force weight, that Ft minus Fw would equal to Ma, and A would be positive. So Ft would equal to Fw plus Ma. So if I'm accelerating upward, I have to exert a bigger force than the weight. If I'm accelerating downward, then the force is less. And if I'm accelerating downward at g, then what is the force required to hold it in place? What is it? Yeah, if I'm in free fall at g equal 10 meters per second squared, the force required to hold that block in place is 0, right? Because I'm in free fall. It's weightless. So watch out for that too. Also, this could all be said the same if I replace Ft with Fn. So if instead of have it hanging by a rope, I just have an object sitting on the floor, that the normal force is the same as Ft. Those questions are the same. It's just replacing Ft with Fn. And if the elevator moves up at a constant velocity, F is equal to the weight of the block. First, I know that 1 and 2 are wrong, so I can get rid of that one, that one, that one, and that one. So I'm already at D. It doesn't really matter what the answer for D is. I know that it has to be correct, and in fact, it is correct. If it's at a constant velocity, the acceleration equal to 0, that means that that force, F, is equal to the weight of the block. Those are good questions. Be prepared for them. I'm pretty sure I remember seeing that figure. It's just the responses will be different, and they could be, wildly different, but approach it the same way. All right? Do y'all understand what I was saying about the normal force being the same as the tension here? If I'm accelerating upward, the normal force is bigger, smaller, or the same as the weight. If I'm accelerating upward, bigger, smaller, or the same? What? Yeah. Bigger is right. If I'm accelerating downward, it's less than the weight. And if I'm at a constant velocity or stationary, it's equal to the weight. Okay. Make sure you understand why that is and that that's true. Yeah, like if I'm accelerating up, that's not a good example. We'll get to that later. It's like in that spinny thing. It's similar to the spinny thing, the gravitron at the Fireman's Fair. You ever do that? Have y'all done that? I don't either, because you throw up and it's disgusting. Anyway, that in that case, you have this normal force that's pushing on your back. That's sort of like going up in an elevator for a different reason, but we'll talk about that in chapter 7. Okay? All right. Other particular questions, y'all? Look, some of these are like this one, for example, is straight from the concept test. So just, FYI. I think that there is a question like this where I have an object that's accelerating, but it's accelerating at a rate that's less than what you would expect. And I ask you to find the force, the resistive force. That might be a frictional force. In this case, it's an air resistance. Let's just take a look at this. So I have a frictional force or an air resistance force. I have a weight, which is equal to 100 newtons. Normally, I would expect this to accelerate at 10 meters per second squared, but I'm told that the acceleration is equal to minus 9 meters per second squared. And so I do the sum of the forces, F minus 100 equals the mass, 10 times minus 9. And so F is equal to 100 minus 90, which is equal to 10 newtons. Pretty sure you have something similar to that. I think it was probably a frictional force, but the process is still the same, right? That if I have an object that has some force acting on it, and there's a frictional force, and I tell you the acceleration, then you can figure out what is that frictional force. Or you can figure out mu, or you can figure out any number of things. Okay? You will have a question like that, I'm pretty sure. They're on most of the exams, so it shouldn't be a big surprise. The exams are all really similar. They really are. Like if you can master one exam, and I don't just mean that you know all the answers, but you master it, then you should be able to do any exam, honestly. All right. What other questions, y'all? Don't forget projectile motion. That's important too. You'll see, well, you'll see one like number 1 where it goes from a horizontal, and then you'll see from beginning to end. That'll be on your free response, the type of question where you go like that. That's your free response. So make sure that you just know that cold. Hopefully y'all do by now, that you just know those really well. But you'll also see one like this. You need to first find the time on this where you're firing horizontally. To find the time, you say y is equal to 1/2 at squared. V naught y is 0. That's minus 125 equals negative 5 times t squared. So t is equal to 5 seconds. And then I ask a variety of questions. In this case, I'm asking the speed when it reaches the ground. Sometimes I'll ask the horizontal range. X is equal to vxt. The speed when it reaches the ground, it has a component in that direction and a component in that direction. I know the first component, the Vx, is equal to 30 meters per second. That doesn't change. Vy is equal to V naught y plus AYT. That's 0 plus negative 10 times 5, or negative 50. And then so to find the answer, it'd be 30 squared plus 50 squared. Whatever that is. Probably 58, I think. 58.3 probably. Be careful on this with your calculator. I see a lot of students making mistakes like this, where they put in a negative 50 right here, and they don't use parentheses properly. If you're going to use that negative, you better put it inside the parentheses. But just don't use the negative at all, because you're squaring the number, and the negative just goes away. Write lots on your exam. Make sure you write a lot as you're working through the exam. It will really help you to see mistakes as you're going along the way. If you're just doing your calculator, you're going to make a lot of mistakes in your calculator. And you're not going to know it, is the thing, because it's once it erases, it goes away. So write it on your paper. You should have some time to go back and look at those questions that you're uncertain about. Say you got some system where you circle the question. Excuse me. Some system where you circle the questions that you're uncertain about. And then go back and check those. Other questions, y'all? No? That's like the shortest help session I've ever had. You sure? Do I have a favorite question? They're all my favorites. Like I said, the exams are all the same, right? If you look at them, there's always one like number 3. There's always one like number 1. There's always one like number 9. The vectors thing. Yeah, there's usually one like number 14. I told y'all there will be one like number 14. There's always one like 15. There's usually one like 13. Yeah. Y'all won't have one like 20. I gave you all the full 20 questions. Okay. That's all? All right, let me stop the recording here. Make sure I get your name before you go.